In our next example, we have a quadratic equation where the value of a is larger than 1. Now, we're not so concerned with the fact that a would be positive or negative, because we could just simply multiply the entire equation by a -1 and rewrite that first term as positive. But in this case, we have a positive first term with a coefficient that is larger than 1, namely this 9 right here. Completing the square as a process fails if the number that's not in front of the square term, if the number that's in front of the square term is not a 1. We need that number in front of the square term to be a 1 for completing the square to work as a process. So in the event that you are given an equation where that lead coefficient is larger than 1, you have a responsibility of dividing every term in the entire equation by 9. Rewriting the equation as x squared minus 2/3 x minus 4/9 is equal to 0. It's after taking that step that we can walk through the process of completing the square. Let's add the 4/9 over to the right-hand side so that our quadratic and linear terms are together on the left. We take our 2/3 that was right here. We divide it by 2 and we square it. You can check my arithmetic on this, but it should be 1/9. 1/9 would be the correct expansion of that division and squaring. So x squared minus 2/3 of x plus 1/9 is what we would write to complete the square. And to keep everything in balance, we're going to put another 1/9 over on the right-hand side. Factoring the left-hand side, we have x minus 1/3 squared. We want to make sure that our sign here matches the sign there. And on the right-hand side, we have 5/9. Solving that equation by using the square root method, we can split it into two different questions. So let's just rewrite that so we have it before we take that square root. So we're going to take the square root of the left side and the square root of the right side. The square root of the left side will create x minus 1/3. And we know there's going to be 2 of them. The square root of the right-hand side creates either the square root of 5/3, because that's just the square root of 9, or negative, the opposite of the square root of 5/3. Adding to solve both of these smaller linear equations, we get x is equal to root 5/3 plus 1/3, and x is equal to the opposite of root 5/3 plus 1/3. Normally, you will see these written so that the constant rational term is first, followed by its irrational part, and especially because they have the same denominator, we can add these two fractions together. And we'll do the same thing over here, 1 minus root 5/3. So here are our two solutions. Again, this original equation that we had back here is going to be unfactorable because we ended up with irrational solutions. Completing the square, quadratic formula are only options, but completing the square, a little bit trickier because of having to take half of a rational number and then squaring that. But if you're ever unsure, when you get to this step, attempt to multiply this out and make sure you get back to the previous line. That's a good indication that you might have just factored something wrong or done some small step incorrectly. But don't forget, when we go through this and we use the square root method to rewrite this, that we're going to need to identify both of the solutions.